This presentation represents one of the final outputs from a project which has explored the relationships between spatial inequality and attitudes to inequality in South Africa. The project has been a collaborative undertaking between researchers at the Centre for the Analysis of South African Social Policy at the University of Oxford and the Human Sciences Research Council in South Africa. The project has been primarily funded by the UK's Economic and Social Research Council, with some additional funding contribution from the South African National Research Foundation. There are three components to the project. The first component focuses on the development of new measures of inequality, and specifically spatial inequality, in South Africa, with a particular emphasis on measuring how people's experience of inequality may vary spatially according to where within South Africa they live. The second component of the project interrogates the South African Social Attitude Survey to better understand people's attitudes to inequality and their attitudes, views and opinions on options for redress in South Africa. And finally, the third component of the project draws upon the findings of the two preceding components to test whether there are any statistical relationships between people's experience of inequality, according to where they live, and their attitudes to inequality. So, are people's attitudes to inequality in South Africa influenced by their experience of inequality as they go about their daily lives in their local geographical settings? This particular presentation focuses on the first component of the project, namely the development of statistical measures of spatial inequality to reflect the ways in which people's experience of inequality varies geographically according to where they live and carry out their routine daily activities. In this presentation, I will first give a brief overview of other examples of spatial inequality research internationally, which set the framework for the current study focused on South Africa. I will then discuss the datasets and geographies that we utilise in our study. I will describe, in summary, the methodology that we developed to measure spatial inequality, and I will give an overview of the headline results. For further detailed discussion of the methodology and further detailed analysis of the results, please see the associated academic journal article and the project report that accompany this presentation. Links to these two written outputs, along with a range of other documentary outputs, are provided on our project website. Over recent years, there has been a notable increase in research emphasis on the issue of inequality. And much of the existing quantitative research concerning inequality utilises the classical measures of inequality, and typically income inequality, such as the Gini coefficient, general entropy measures, or the Atkinson index, and is expressed at a high spatial level, usually national level or at best provincial level. These measures of classical income inequality can be extremely powerful, especially for looking at change over time within a country or for looking at cross-country comparisons. The classical measures are often based upon survey data, such as national income and expenditure surveys. However, these measures say little about people's lived experience of inequality, and importantly, how this may vary geographically within a country. In other words, they say little about how geography can help to shape people's experience of inequality. We argue that people's experience of inequality is not uniform across all of South Africa, but rather that it is contoured by the geographical settings in which they live, work, socialise and travel. In other words, the local settings in which people undertake their routine daily activities. And because people typically undertake their routine daily activities within a quite localised geographical setting, we argue that an appropriate measure of spatial inequality, which is designed to reflect people's experience of inequality, requires a neighbourhood level approach. Internationally, most analyses of spatial inequality at neighbourhood level use measures of residential segregation. Residential segregation indices measured the degree to which two or more population subgroups live separately from one another at a small area or neighbourhood level. These measures distinguish between different categories of the population. Many of the early developments in the field of residential segregation research focused on segregation between different racial groups within US cities. Measures of residential segregation are therefore constructed using categorical data. In our project, we have applied and developed a range of these indices of residential segregation to measure segregation between the poor population and the non-poor population across the whole of South Africa. Our categorical classification is therefore a dichotomous distinction between poor and non-poor. Our aim has been to develop a measure of residential segregation that reflects people's lived experience of inequality in South Africa, and which varies according to where within South Africa people live and carry out their routine daily activities. And our motivation was to develop these measures to act as explanatory factors in helping us to better understand people's attitudes to inequality and potentially their action responses to inequality. In order to operationalise this, we require a dataset that counts the number of poor people and the number of non-poor people in each neighbourhood across the whole of South Africa. This enables us to explore the unequal spatial distribution of poor and non-poor people across the country. The data we utilise to construct measures of spatial inequality for this project are drawn from the South African Index of Multiple Deprivation 2001 at data zone level, or SAIMD for short. The SAIMD was constructed by researchers at the Centre for the Analysis of South African Social Policy at the University of Oxford, in conjunction with partners in South Africa, on behalf of the South African National Department for Social Development. The SAIMD is expressed at data zone level and covers the whole of South Africa. It allows each neighbourhood to be ranked from the least deprived neighbourhood to the most deprived neighbourhood on a range of different dimensions of deprivation, as well as an overall composite measure of multiple deprivation. The SAIMD has been used by national, provincial and local government to help target anti-poverty policies in the most deprived neighbourhoods. The SAIMD is based upon census data from 2001, and we were very grateful for the support of Statistics South Africa in granting us permission to access and utilise the full 100% individual level census data set for this purpose. As you can see on the screen, the SAIMD consists of 5 separate component dimensions, or domains, of deprivation, each of which was constructed at data zone neighbourhood level. 4 of these domains were constructed to represent the percentage of resident population per neighbourhood that was deprived on that particular domain. So, for instance, in the income and material deprivation domain, the indicator represents the percentage of population per neighbourhood defined as experiencing income or material deprivation at the time of the 2001 census. Health deprivation was measured differently, using an age-sex standardised mortality approach, but again using the 2001 census. As I noted earlier, the construction of residential segregation measures requires categorical input data. For our current project, we could therefore use any of the 4 domains from the SAIMD that are expressed as the percentage of population deprived, because each of these 4 domains is based on a dichotomous classification of either deprived or not deprived. For the purpose of our current research into spatial inequality in South Africa, we utilised the income and material deprivation domain of the SAIMD. In this domain, people are regarded as suffering income or material deprivation if they meet one or more of the following 3 criteria. Either they are living in a household that has a need-adjusted household income that is below 40% of the mean equivalent household income, or they are living in a household without a refrigerator, or they are living in a household with neither a television nor a radio. So as you can see, the definition of income and material deprivation adopted here clearly has the income component, in terms of the equivalised household income threshold, but also the material deprivation component in terms of living in a household without particular socially perceived material necessities. Everyone in South Africa who was enumerated in the 2001 census has therefore been classified according to this definition as either deprived or not deprived in terms of income and material deprivation, or, to express it another way, as being either poor or non-poor. As such, these dichotomous data provide a valuable input data set into our construction of residential segregation measures in our analyses of spatial inequality. As I mentioned, the SIMD was constructed and presented at data zone level. Data zones are a relatively new statistical geography covering the whole of South Africa, originally developed for the specific purpose of constructing socio-economic indicators for the SAIMD. Unlike conventional geographical units, such as electoral wards, which vary greatly in terms of their population size, from populations of just a few hundred to populations of many thousands, data zones were specifically designed to have relatively equal populations, ranging from a low of 1,000 resident people to a high of 3,000 resident people, with a target mean of 2,000 resident people. In other words, data zones are a statistical neighbourhood level geography, which allow neighbourhoods to be compared on a like-for-like basis due to their similar population sizes. Data zones are also small enough in terms of population size to enable geographical pockets of poverty and deprivation to be identified, which might otherwise be missed if looking at larger geographical areas. They therefore facilitate a fine-grained geographical analysis to be undertaken. There are approximately 22,000 data zones across South Africa as a whole. This map shows the configuration of data zone neighbourhoods in and around the city of Johannesburg. The thicker dark grey line shows the municipality boundary for the city of Johannesburg, and the thinner light grey lines show the configuration of the constituent data zones within and immediately around the city of Johannesburg. And just to recap, each of these data zones depicted on the map contains a resident population of approximately 2,000 people. And for geographical clarity, I've also superimposed a close-up of the Alexandra township. The income and material deprivation domain of the SIMD quantifies what proportion of the population in each data zone neighbourhood is defined as deprived on this particular domain. In other words, what proportion of data zone population is poor and what proportion is non-poor. In this map, thematic colour coding is used to highlight the spatial variation in neighbourhood poverty rates across the city of Johannesburg. The dark green areas are data zones where between 0 and 10% of the resident population is defined as poor, ranging through to the bright red areas, which are data zones where between 90% and 100% of the resident population is defined as poor. It is quite clearly apparent how the city of Johannesburg has a wide variation in poverty rates between the constituent neighbourhoods. For instance, the northern suburbs in and around Sandton are typically characterised by relatively low rates of poverty, while the areas in and around Soweto, Alexandra and the outer lying townships are typically characterised by very high rates of poverty. This map therefore provides a very stark visual indication that the city of Johannesburg is characterised by high levels of spatial inequality. Now, whereas the city of Johannesburg is a major metropolitan area of South Africa and highly urbanised, this can be contrasted with an area such as the King Sabata Dalinyebo municipality in the Eastern Cape, which is largely rural. Again, on the map here, we see the municipality boundary in the thicker dark grey line and the constituent data zone neighbourhoods in the thinner light grey lines. Again, each one of these data zone neighbourhoods contains approximately 2,000 resident people. When poverty rates are shown for the neighbourhoods in and around King Sabata Dalinyebo municipality, again using the same colour coding scheme as I described for the city of Johannesburg, we see a notably different spatial pattern, than was observed for Johannesburg. Primarily, the vast majority of data zones in and around King Sabata del Niebo municipality are colour-coded bright red, indicating that between 90% and 100% of the resident population of these data zones is classified as poor. Whereas in the city of Johannesburg there was a broad spread between high poverty rate neighbourhoods and low poverty rate neighbourhoods, which suggests a relatively high degree of inequality between neighbourhoods within Johannesburg. When we look at King Sabata del Niebo municipality, there are only a small geographical pockets of relatively low poverty neighbourhoods, with vast swathes of the municipality characterised by extremely high poverty rates. In other words, King Sabata del Niebo municipality exhibits a more homogeneous poverty rate coverage than was observed in Johannesburg, and therefore potentially less inequality between neighbourhoods than was observed for Johannesburg. Although the poverty rate data shown in the maps of Johannesburg and King Sabata del Niebo municipalities give a visual indication of the uneven spatial distribution of deprivation across South Africa, these poverty rates can also be used as input data into the calculation of measures of residential segregation. For the purpose of our project, we utilised the framework for the measurement of residential segregation proposed by Douglas Massey and Nancy Denton in 1988, in which they identify 5 distinct dimensions of residential segregation and give a number of statistical measures of each. Massey and Denton's dimensions of segregation are evenness, exposure, concentration, centralisation and clustering. As part of our current research project, we constructed and reviewed a series of statistical measures across Massey and Denton's 5 dimensions. We reviewed each of these statistical measures, both conceptually and methodologically, for their relevance in providing a geographically contoured measure of the lived experience of inequality. The accompanying academic journal article and project research report provide a detailed justification for our rejection of measures of evenness, concentration and centralisation. Our chosen empirical measure is a modified form of the distance-weighted exposure index, which Massey and Denton classify under their clustering dimension, but which we believe clearly straddles the 2 dimensions of exposure and clustering. I will now provide a brief introduction to our chosen distance-weighted exposure index, and I will then proceed to present some headline results. Massey and Denton recommend the so-called P-exposure indices, which measure the extent to which members of one population subgroup are exposed to members of another population subgroup. They represent the likely interaction of members of different population subgroups. For our purpose, we are interested in the extent to which the poor are exposed to the non-poor, and the extent to which the non-poor are exposed to the poor. Whereas the classical income inequality measures, such as the Gini coefficient, provide a single overall summary statistic for the entire population, the P-star exposure indices enable exposure to inequality to be measured separately from the perspective of the 2 constituent population subgroups, in our case the poor and the non-poor. This represents a major strength of the exposure indices over the alternative measures under the other dimensions of Massey and Denton's classification. These exposure indices essentially represent the likelihood that individuals will be exposed to people from the other end of the socio-economic spectrum as they go about their daily lives. And we would argue, therefore, that they may be regarded as proxies for an individual's lived experience of inequality. As we discuss in detail in our academic journal paper and our project report, there are different variants of the exposure indices, these being global, geographically weighted and local variants. The local variant gives the greatest degree of geographical nuance, and so it is a local variant that we adopted for our current study. A crucial parameter in the construction of our exposure indices is the definition of spatial bounds within which individuals may potentially be exposed to socio-economic inequality. We would argue that people's potential exposure to inequality relates very much to the locations in which they undertake their daily routine activities. So where they work, where they live, where they study, shop, socialise and travel, etc. Now unfortunately, at the present time, there are no nationally consistent, reliable data on people's travel patterns that we can draw upon. We therefore have to make some assumptions. Our chosen approach in this regard involves two particular methodological components. The first component is to restrict people's routine daily travel patterns to occurring within their own home municipality and or within a 20-kilometre radius of their home neighbourhood. This is a combination of two fairly standard approaches to setting spatial bounds in this type of research, namely restricting potential interactions to within a possibly fairly arbitrary administrative area, and restricting potential interactions to locations within an, again, possibly fairly arbitrary set distance radius. By combining these two approaches, we maximise the strengths and minimise the weaknesses of each. The second component of our methodology in this regard concerns the likelihood of an individual visiting each separate neighbourhood within these defined spatial bounds. We propose that this likelihood is determined by two factors. Firstly, the distance between respective neighbourhoods, with people more likely to visit neighbourhoods that are close to their home neighbourhood, in other words, the conventional distance decay approach. And secondly, the respective levels of poverty within and between neighbourhoods. This is because we recognise that the likelihood of people visiting one neighbourhood versus another neighbourhood is not uniform and is not simply a function of distance, but rather it is contoured by a combination of needs, opportunities and barriers. Our assumption here is that the more affluent neighbourhoods may exert stronger pull factors than the more deprived neighbourhoods, due to affluent areas typically being sources of potential employment opportunities and service access opportunities. We turn now to look at some of the headline results. For the purpose of this current project, we constructed two separate but complementary exposure indices. One which measures the lived experience of inequality from the perspective of the poor population, and another which measures the lived experience of inequality from the perspective of the non-poor population. In the remainder of this presentation, I will focus on the experience of inequality from the perspective of the poor. However, in our accompanying project report, we provide a comprehensive analysis of the results of both exposure indices, reflecting the experience of inequality from both the perspective of the poor and the perspective of the non-poor. Firstly, this map of South Africa includes every single data zone across the entire country. The data zones have been ranked and deciled according to their scores on the relevant exposure index, which is, as I said, the degree to which the poor are exposed to the non-poor, which we believe reflects the experience of socio-economic inequality from the perspective of the poor. The 22,000 or so data zones across the country have been split into 10 equal deciles, and these deciles have been colour-coded according to their scores on the exposure index. The dark blue areas are the 10% of data zone neighbourhoods across the country that have the highest levels of exposure to socio-economic inequality from the perspective of the poor population, while the bright yellow areas are the 10% of data zone neighbourhoods with the lowest levels of exposure to socio-economic inequality from the perspective of the poor population. What we can see visually from this map is that the areas with the highest levels of exposure on this measure appear to be located in the more urbanised areas, particularly within the provinces of Gauteng and the Western Cape, but also some geographical pockets of high exposure in eThekwini and other metropolitan areas. Now, clearly, a national map such as this does not show the geographical detail that is one of the key strengths of this type of exposure measure. Because all the data zones contain approximately the same population of around 2,000 residents, the more densely populated urban neighbourhoods will be considerably smaller in terms of geographical size than the more sparsely populated rural neighbourhoods. And so, in order to better understand the uneven spatial distribution and exposure levels, it is necessary to look at a combination of tabular data and some case study maps. This table focuses specifically on those dark blue neighbourhoods shown on the exposure map we just looked at. These are the 10% of data zone neighbourhoods across South Africa with the highest levels of exposure to socio-economic inequality amongst the poor population. Here we see that, in total, there were 2,216 neighbourhoods in that highest exposure decile. Of these, almost half, 986, were located in the city of Cape Town, with a further 502 in Tshwane, plus 290 in Johannesburg, and 206 in Ekurhuleni. These four major metropolitan areas therefore account for approximately 90% of the dark blue, highest exposure neighbourhoods across South Africa. The remaining 232 dark blue neighbourhoods were split amongst a further 23 additional municipalities. So from this table we can see very clearly that the neighbourhoods with the very highest exposure levels are overwhelmingly located within the major metropolitan areas of Cape Town, Tshwane, Johannesburg and Ekurhuleni. However, these major metropolitan municipalities do of course contain large overall numbers of constituent data zones due to the large resident populations of these municipalities. It is therefore important to also look at the proportion of data zones within each municipality that fall within the highest exposure decile nationally. These data are shown in this particular table. Here we see the 10 municipalities across South Africa which have the largest proportions of their constituent data zones in the highest exposure decile nationally. Top of the list is the local municipality of Gamagara in the Northern Cape. Now we can see here that this is a very small municipality consisting of just 9 data zones in total. But of these 9 data zones, 7 fall within the highest exposure decile nationally. The second position in this table is held by Stellenbosch municipality in the Western Cape, where, of the 60 data zones in total in the municipality, 44 are in the highest exposure decile nationally. Cape Town comes third, and we can see here that Cape Town consists of 1,388 data zones in total, so vastly larger than the 2 municipalities above it in the table. And as we saw from the previous table, 986 of these data zones in Cape Town are in the highest exposure decile nationally. So, therefore, over 70% of the data zones in the City of Cape Town Metropolitan Municipality are within the highest exposure decile nationally, when looked at from the perspective of the poor population. The remainder of the table consists of some smaller municipalities, but also the 3 other major metropolitan municipalities that were highlighted alongside Cape Town in the previous table. So the City of Tshwane contains 951 data zones in total, of which 502, or just over 50%, are in the highest exposure decile nationally. The City of Johannesburg contains 1,599 data zones in total, of which 290, or approximately 18%, are in the highest exposure decile nationally. And Ekurhuleni contains 1,188 data zones in total, of which 206 fall in the highest exposure decile nationally. So the 2 tables together show that, firstly, the overwhelming majority of the highest exposure neighbourhoods nationally fall within these 4 major metropolitan areas, and secondly, fairly large, and in some cases very large, proportions of the constituent data zones within these 4 metropolitan areas are characterised by the highest levels of exposure nationally. Whilst the tabular data provide a valuable sense of how municipalities compare against one another, the real strength of these locally constructed exposure indices is that they enable analyses of spatial patterns within municipalities as well as between municipalities. In this slide I will present 2 examples to demonstrate this, again using the municipalities of Johannesburg and King Sabata Dalanyebo as our case study areas. As we saw earlier, these are the data zone boundaries within and around the city of Johannesburg. And onto these boundaries we can display the exposure scores that we saw in the earlier map that spanned the entire country. Here we can see the spatial differentiation within Johannesburg, where the predominantly quite affluent northern suburbs in and around Sandton are colour-coded dark blue, meaning they are in the 10% of data zones nationally with the highest levels of exposure amongst the poor population. Poor people living in these affluent northern suburbs have very high exposure to socio-economic inequality as they go about their daily lives. In Soweto, however, where we saw earlier that poverty levels are much higher than in the northern suburbs, we see that the data zones are typically colour-coded a lighter shade of blue, which is indicative of being in decile 8 of the national distribution. So, relative to the rest of South Africa, poor people in Soweto experience quite high levels of exposure to inequality, but not as high as poor people living in the typically affluent northern suburbs. And when we look at Alexandra, which we saw earlier was also characterised by high levels of poverty, we see the data zones are typically colour-coded as mid-blue, which is indicative of being placed within decile 9 on the exposure measure, meaning that a poor person in Alexandra is likely to experience greater exposure to socio-economic inequality than a poor person in Soweto, but less exposure to socio-economic inequality compared to a poor person living in a place such as Sandton. Now this of course makes a lot of sense, because if you are a poor person living in a broadly affluent area such as Sandton, then you will be extensively exposed to socio-economic inequality as you go about your daily life, both through interactions or potential interactions with affluent individuals, and through observing the very obvious visual signs of affluence, such as expensive housing, cars, shops, etc., that certain sections of the South African population enjoy. If you are a poor person living in Alexandra, however, then whilst many of your immediate neighbours are likely to be poor, your spatial proximity to the affluence and wealth of Sandton mean that you are still likely to experience very high levels of exposure to socio-economic inequality. And with regard to Soweto, which is a greater geographical distance away from Sandton than Alexandra, and which is internally slightly more heterogeneous than Alexandra in terms of neighbourhood poverty rates, we see exposure levels which are relatively high compared to the rest of the country, but typically lower than those observed in Alexandra. If we turn now to the King Sabata Dalanyeba municipality in the Eastern Cape, we can again see the data zone boundaries, and we can again overlay the exposure deciles in exactly the same way as shown for the city of Johannesburg on the left. Here we can see that overwhelmingly the areas in and around King Sabata Dalanyeba municipality are characterised by substantially lower levels of exposure to inequality amongst the poor population than we observed within the city of Johannesburg. The data zones are typically colour-coded yellow through to light green, indicating that these areas fall within the lower end of the national distribution of exposure scores. This is, of course, and as shown in the earlier map of neighbourhood poverty rates, because if you are a poor person living in the predominantly rural areas of King Sabata Dalanyeba, then almost everyone else living around you is also classified as poor according to our adopted poverty definition. And so there are far fewer opportunities to interact with non-poor people, or indeed to observe the visual signs of affluence and wealth as you go about your daily life. But even within and around the municipality of King Sabata Dalanyeba, there is some variation in exposure scores. A poor person living in the town of Mthatha, for example, which we saw on the earlier poverty rate map was an area that combined some low poverty rate data zones, will have a higher exposure to inequality than a poor person living in the surrounding rural areas due to the closer proximity to non-poor people and the potential visual signs of affluence within the town. In light of this, we see that exposure levels reduce as distance from Mthatha increases. We believe that these exposure indices provide a valuable indicator of a person's lived experience of inequality, which we believe may represent important explanatory variables contributing towards the shaping of people's attitudes to inequality. And indeed, as I explained at the beginning, this is the main overall focus of the research project that these exposures indices feed into. However, we also believe that these exposure indices may represent important explanatory variables for other social phenomena. For instance, identifying neighbourhoods that may be particularly vulnerable to social unrest and/or violent crime. However, when looking at potential risk factors associated with area-based phenomena, such as social unrest and violent crime, it is important to look not only at the role of exposure to inequality from the individual perspective, as shown here, but also to recognise and reflect the numbers of poor people who are exposed to high levels of inequality. As such, it is important to consider our exposure indices in conjunction with the poverty rate measures that we looked at earlier on in this presentation. To illustrate, if we take a hypothetical poor person that lives in the affluent suburb of Santon, we can see from the map on the left that this poor person would likely have very high levels of exposure to socio-economic inequality, because he or she will be living in a neighbourhood with relatively few other poor people. And we can contrast this with a hypothetical poor person living in the township of Alexandra, essentially just across the road from Santon, where we can see from the map on the right of the screen that poverty levels are very high, meaning that substantial numbers of people are poor, and these poor people have very high levels of exposure to socio-economic inequality. As part of our current project, we will test whether there are any statistically significant interaction effects between neighbourhood poverty rate and exposure to inequality score, as we believe that when the population of a neighbourhood is both poor and highly exposed to socio-economic inequality, then this may generate a strong community sense of social injustice, which may influence people's attitudes to inequality, and indeed action responses to inequality, over and above the separate explanatory effects of the two variables. In our statistical models that we will present and discuss in the fourth presentation in this series, we incorporate the exposure score as one explanatory variable, the neighbourhood poverty rate as another explanatory variable, and we also include the interaction between them. However, to illustrate cartographically in this presentation, it is possible to map the equivalent of the interaction effect, again using colour-coded national deciles. So, if we retain the map of exposure and the map of poverty rates for the city of Johannesburg, we can then produce the interaction term by multiplying one by the other to calculate what we have tentatively called intensity, to represent the community level intensity of exposure to inequality. The data zones across South Africa have been ranked on this intensity measure and divided into 10 equal decile groups, with the 10% lowest intensity data zones colour-coded bright yellow, and the 10% highest intensity data zones colour-coded dark blue. On this map of community level intensity of exposure, we can see quite clear spatial patterning. If we look first at the affluent areas of Stanton, where levels of individual exposure are high, but neighbourhood poverty rates are low, then we see that these neighbourhoods are typically colour-coded yellow or light green on the community intensity map, meaning that they are characterised by low levels of community intensity of exposure relative to other areas across the country. However, in the townships of Alexandra and Soweto and other outer-lying townships, we see quite high, and in some cases very high, levels of community intensity of exposure. This is because people in these neighbourhoods are faced with the twin stresses of living in areas of high poverty and high exposure to inequality, and it is these areas that we believe may be most at risk of social unrest and/or violent crime. So, to conclude, we believe that spatial inequality measures, and particularly the distance-weighted P-star exposure indices of residential segregation, offer a valuable contribution to the evidence base concerning socio-economic inequality in South Africa. We believe they provide a means to examine geographical patterns in people's lived experience of inequality. They can be used as explanatory factors when analysing attitudinal data, as is the focus of this current research project. but they can also be used to identify geographical areas that are characterised by the twin stresses of high poverty rates combined with high exposure to inequality, which may potentially be most at risk and vulnerable to social unrest and or violent crime. And indeed, a separately funded collaborative research project between the Centre for the Analysis of South African Social Policy at the University of Oxford and the Human Sciences Research Council in South Africa has recently commenced, which will include an exploration of statistical associations within South Africa between violent crime rates and various explanatory factors, including neighbourhood poverty rates, measures of individual exposure to inequality, and measures of community intensity of exposure. For further information about the research discussed in this particular presentation, or indeed for further information on any part of the wider project, please contact either myself at the University of Oxford or Ben Roberts at the Human Sciences Research Council. Thank you.